Alright, to assist you on your homework for the second day of 5.4, again, I'm going to take a look at 4 problems. The first one is kind of like the last two I did for their homework help, just because, again, I know this is one that gives people a little trouble. Once you get the hang of it, you're fine. It just takes a little time. Find the exact value of the cosine of u minus v, given that the sine of u is negative 7/25, cosine of v is negative 4/5, and they're both in the third quadrant, u and v. Then we are going to get a verifying problem, so being able to recognize that this is a sum and difference, and being able to expand it out and eventually simplify it to that. The third one is simplifying. Remember, like when we did in 5.1, 5.2, I would not give you simplify. I would tell you to verify that this is equal to this. So this is the actual answer that you're looking for. And then the last one will be using the sum and difference formulas. Can I solve an equation now instead of just simplifying or verifying? Alright, so back to the first one. And like the last two that we did yesterday, there's a couple things you want to do before you start throwing numbers in, and one of them is I want to expand that out. So the first thing that I would need to do is figure out what is the cosine of u minus v property. And so when I look it up, I can see that that is equal to the cosine of u times the cosine of v plus the sine of u times the sine of v. So there's what this is going to expand into. That's one thing I want to do. The other thing I want to do is I want to draw right triangles for this, because although I do know what the cosine of v is, I don't know what the cosine of u is, and I don't know what the sine of v is. So there's some things that I don't know. So I'm going to draw myself a triangle to help figure that out. So remember, these are both in the third quadrant, so make it look like it's in the third quadrant. This is going to be angle u, and we said that the sine of u is negative 7/25. So 7/25, the hypotenuse can't be negative, so this must be negative, and of course it makes sense if you actually take a look at it. And then if you run through your Pythagorean theorem, you're eventually going to find out that this is a Pythagorean triple, and this number is 24. And why is it important it's in the third quadrant? It's negative. And that'll be a little detail that if you don't see, it's obviously going to throw your answer off. Alright, now if I look at angle v, we said the cosine of angle v was negative 4/5. So negative 4, whoops, I said the cosine, didn't I? So here's the negative 4, here's the 5, and then this is a 3, 4, 5, or Pythagorean triple, so this is 3. Again, make sure you catch that it's negative. Alright, now I can evaluate each one of those. So I look at my triangles. Cosine of u, well here's the u triangle. The cosine is negative 24/25. Cosine of v, here's the v triangle. Cosine is negative 4/5. Plus sine of u, sine is negative 7/25, times the sine of v, which is negative 3/5. Now, I would normally try to simplify here if I can. Nothing looks like it will. The good news is I do have a common denominator right away, so that's nice. So I'm going to have to multiply 24 times 4, and like I said, you can multiply that out by hand if you need to, or double it once gives you 48, double it again gives you 96, and it'll be positive. If I had 4 25s, it'd be 100, so this is 125. Plus double negative, so it'll stay positive 21 over 125. And now I just have to add 21 and 96, and I end up with 117 over 125. And again, when I get numbers like that, they're a little bit large. So you do want to try to simplify if you can. And for this particular one, it won't simplify. I know that it won't simplify because I tried to simplify up here and it didn't happen, so I know that it won't simplify. Alright, so there's that one. The next one is doing a verifying problem like we did in section 2. So I'm going to have to look up the identity for this and the identity for this and expand them both. So look at the first two identities that we wrote down on the board the other day. This will expand out to the sine of x times the cosine of y plus the cosine of x times the sine of y. So just write off the identities that we had. Plus, this plus. Now I need to expand this one out. And again, if I look at my identities, this is going to end up being the sine of x times the cosine of y minus the cosine of x times the sine of y. So make sure that you do get the right identities. And then if you look at this, I have a positive cosine x sine y, a negative cosine x sine y. They will cancel. These two are exactly the same, so if you have two of them, added together, you're going to get 2 sine x cosine y. And there is my answer. Remember, you're not supposed to do anything with the right side. You're just supposed to get the left side to look like that. So for the most part, a quick little problem, just assuming you remember what your identities are. All right, so number 3 that we're going to do, same thing basically. It says simplify, but again, look up the answer for a simplified problem so you know what you're trying to get to. And now I'm going to look at my identity. So I look up the identity for tangent. It's being added. It's going to be the tangent of pi plus the tangent of theta divided by 1 minus the tangent of pi times the tangent of theta. Now trying to get that to simplify to the tangent of theta. Well, the tangent thetas, there's nothing I can do, but these two, I know what the tangent of pi is, or I can figure it out. So if I think of pi on my unit circle, I know pi is over here. I know that point is -1, 0. The tangent, y divided by x, would be 0. So this is actually equal to 0 plus the tangent of theta divided by 1 minus, of course if this is 0, it doesn't matter what that is, it's going to be 0. So I end up with the tangent divided by 1, or of course that's just tangent of theta. And so I've proven or verified or simplified this term into that. Like I said, for the most part, these are quick as long as you get the identities right and you don't make a mistake with your unit circle. The last one, now we are going to solve basically this equation, and my answer should be in the interval from 0 to 2 pi. All right, well, same idea as before. I want to have the same trig function. I do, that's wonderful. I notice that this is a sum difference, and I have identities for those, so I'm going to expand both of these out and then try to combine like terms if I can. So starting with this one, I know that the rule says it's the sum of a sine function, so it's the sine of x times the cosine of pi over 6 plus the cosine of x times the sine of pi over 6. So there's that term expanded. Minus, now be careful because I'm subtracting that whole thing, so make sure you've got a parenthesis around this. Minus sine of x times cosine of pi over 6. Make sure you get the right identity. This is minus, so you want the second one we've written down. So it's minus the cosine of x times the sine of pi over 6. And that's equal to 1/2. Most common mistake for this problem is not seeing that negative goes to both of those. So make sure you distribute to both of those, and when you do that, you can see that these two are identical. This one's positive, this one's negative. They are going to cancel. You can easily figure out what the cosine of pi over 6 is, and eventually you're going to see they're going to cancel. This will switch into positive, and you now have 2 cosines of x times the sine of pi over 6 is equal to 1/2. You can easily identify or figure out what that is. The sine of a 30-degree reference angle should give you 1/2. 1/2 times 2, of course that gives me just 1. I'm looking at where is the cosine of x equal to 1/2. And so now, even though you probably can do this without doing this, I want you to again draw yourself a little circle so you can quick identify which quadrant you're supposed to be in. And I know if I have a 1/2 for the x value, that's a reference angle of 60 degrees or pi over 3. And this would end up being 5 pi over 3. And there are my two answers. So by and large, if you have your identities down correctly, you don't end up looking at the wrong one. For the most part, I think you'll think the homework for this is a little bit easier. If you do have trouble, that's fine. Don't feel bad. Just feel free to come in and ask for help.